Compaction curve and saturation contours. Again, I think that was really more of just a misunderstanding. What's required? First, plot the compaction curve. But I will talk about that very briefly because Noah, was that you, I think, maybe? Um, After you plot the compaction curve, which might look something like that, something like that. Okay. You put on your 4 or 5 data points and you connect the dots with a smooth curve. Okay. From that, the peak of the curve tells you gamma D max and right down from the peak in a compaction curve is always water content versus dry density. Okay, so here is no such thing as maximum water content. That's another common mistake. Okay. Maximum dry density, yeah. The optimum water content is the one that corresponds to maximum dry density. So then the question that you asked about after you do all this, and the question gives you the data, first calculate all of this stuff. And then it says, range of water content corresponding to 90%. So if here's gamma D max, how about I go to 90% of that? 90% relative compaction, in other words, 0.9 gamma D max. If I go to that value of gamma D and come across the chart like so, this gives me a range of water contents. Only optimum will get me to the peak. But this whole range of water contents will get me to at least 90%. And so that's what they're asking. The range of moisture content to get at least 90%. So here's X and Y, limits of water content that will allow at least 90%. Okay, and then do again, same thing. It asks for 0.95% relative compaction. In other words, 0.95 gamma D max. Do the same thing. Come across here. That gives me a range of water contents where as long as I'm in that range, I should be able to get at least 95% relative compaction. Okay, a range of water contents will be allowable to get the high enough density. Cohesive particles stick together, and therefore vibration won't work. That's the answer. Okay?
Okay.
Incohesive, use vibration. Okay? Static pressure will not work. There's too much friction between the sand and gravel particles. You can't just squeeze it and decrease its volume to make it more dense. It won't work for incohesive particles. But like you said, tiny flaky particles, well, the clay and even somewhat the silt, if there's a significant amount or if it's mostly clay or silt, then the cohesive soils, vibration will not work. Static pressure is okay. You can squeeze the clay. High pressure, long term, it will squeeze. It will compress and densify. Yeah, but much better is kneading. A kneading action, which really is, shears the material, shears the soil, or sometimes called manipulation. All three of these are really the same thing. Kneading, shearing, manipulation is much better. Okay? Vibration will not work if the particles are sticky, which is what we call cohesion, right? And plasticity. And so what this idea then leads to is all the other methods and techniques that we're going to talk about. It all comes down to this, right? Use, you know, um, dynamic, dynamic energy slash vibrational energy, as opposed to not statics, but static energy or just static pressure, right? So static, dynamic, impact, and needing shearing. Those are the four types. Okay, and I'll come back to that. Again, we'll talk about that quite a lot more extensively tomorrow. But it all starts with that. Okay. All right, very good. What else? What else do you want me to talk about? Okay. Well then, suppose we can get into it.